Hello guys, welcome back. In previous lesson, if you remember, we talked about measures, central tendency and dispersion. Today we will continue a statistics topic with this title, percentile concept. This is very important and we will refer to this topic in the future lessons, so we should learn it. And a good news, this is very easy topic. And after this video we have an Excel lesson that covered all previous topics that we talked. Okay, yes, we are going to practice in Excel in the next video, but for today let's start this video, percentile concept. Let me start this lesson with an example. The 20th percentile is the value below which 20% of the observations may be found. A percentile is a measure used in statistics indication the value below which a given percentage of observations in a group of observations fall. When you say midpoint, there are 50% of the value below the median value and 50% are above the median value. So, median value is the 50% value. As we studied, median is the midpoint. In other words, 50% of the values are below the median value. Median value, also called as 15th percentile value. As example, let's say you are the fourth tallest person in a group of 20. So there are 20 individuals. If you are the fourth person, it means that 80% of the people are shorter than you. Why 80% of the people? 4 by 20 equal 20%. So 20% of the people are above and they are before number 4. So 80% of the people are shorter than you. Let's say which implies that if 80% of the people are shorter than you, you are the 18th percentile, right? And if your height is 1.85, then you can say that there are 80% of the people below 1.85. We will use this concept at a later point in the time, but I want to get this one when we are discussing the median, because median is the 15th percentile value. So this is the concept of a percentile. Now let's move to the other measures, which is dispersion measure. So you remember, like when we were starting the section, we discussed about two measures, and one is the central tendency measure, which are mean, median, mode. The other one is a dispersion measure, which measures the variation in the data. If you forget, just have a review on previous lesson. So those are your range standard variables. So range is the difference between the minimum and maximum. Example. So there is set of values like 2, 4, 6, 8. Range is nothing but 8 minus 2. So it's the difference between the minimum and maximum value. The most important discussion measures are variance and standard deviation. So, variance and standard deviation measures how far or close the observations are from the mean value. So, variance and standard deviation are closely related. In other words, variance is a measure of average distance between each observations and the mean. So it shows the dispersion from the mean, how far the observations are from the mean. It shows the dispersion in the mathematically. As I said, standard deviation and variance are very close, right? The standard deviation is simply the square root of the median. So, if you calculate the variance, you get. If you calculate the standard deviation, both are very much the relate. So, to summarize, variance and standard deviation of a dispersion measures, it describes how far the observations are from the mean. That the farther the observations are from the mean, variance in the data will be larger, and more the observations are closer to the mean, lesser is the variance in the data. As I said, is nothing but a square root of variance, as you can see in this formula, and sometimes in -1 is the number of observations. So if you see an example, it would be clear, and a -1 is used in the denominator. They don't differ in much. They don't differ in much. So, as analytics professionals, we should not be bogged. We should not be bogged down by all these formulas. What is important is the interpretation. The concept here is that -1 is used for deriving the variance or standard deviation of the sample, whereas n is used to calculate the standard deviation of a population. Okay, so as analytics professionals are persons who want to have the key in analytics, the key thing is the interpretation, not the formula. So with this, let's move on to an example of dispersion. Let's take a funny example. You and your friends have measured the heights of your dogs in millimeters. Let's say these are the dogs. Measure the heights and shoulder of all these dogs. For example, I mean a black one, this dog has 600, and then this other one has a 470 millimeter, and so this dog, which is small, has 170, and this is 430. So these are the height set shoulders. Now let's say you are asked to calculate the mean, the variance, and the standard deviation of these dogs. So you know what I mean is simply the sum of all observations, the number of observations. So 600 plus 470, 170, 430, and 300 divided by 5, because there are 5 number of observations. So 394 is the average or the mean height of these dogs. How do we know the standard deviation on various types of before looking into the standard deviation or variance first? Let's look into the shot here. If you see here, the mean height is 394 millimeters, which we saw in the previous heights previously. Uh, so the main line is the green line that you can see here. There are some ducks that like this one, I mean a sausage duck. Yes, this type called a sausage, which is below the mean. So no variances, nothing but how far the observations are from the mean. Attention, how far the observation is from the mean, and the mean is green line is 394 millimeters, right? Right. Take this individual, this black dog. This type should be Rottweiler. This is 206 millimeter above the mean. Yes, this is 600 minus the 394 and equal to 206. So you square it. Similarly, the second dog is 76 and higher than green line, so square it. Next one is 224 millimeters laser, so 224 square. Similar, we have 36 square and 94, right? So it's nothing but squaring the differences and dividing by the number of observations. So this will lead to the variance of 24.704. This is variance, and the standard deviation is simply the square root of the variance. So it will come down to 147.32. So it's the nearest to the mean. It's simple. Variance is nothing more how far the observations are from the mean. Therefore, you just square root of and just added and divided by the number of observations. As I said again, there are elements and we don't need to calculate all these things in our day, and that is just for a better understanding of the concepts. And about the standard deviation, which is 147.32, you got the standard deviation. So what is the use of the standard deviation? This is how you are going to use the standard deviation. As we saw, the mean line is 394, which is green line, and the standard deviation is 147, and blue line. Yes, there is two blue line. A standard deviation is a very important metric. What you can do from disease, which are higher, abnormally higher, and abnormally low, right? So this black dot is above the standard deviation. We can say this is abnormally high rates of these dogs. If you see this dog, sausage dog, this dog is like one standard deviation lesser than the mean. So this is abnormally short, and there are some in between. So these are within the normal range. So to summarize, the standard deviation will tell you how far an observation is from the mean. Standard deviation is standard way of knowing what is normal or extra large or small. So there can be two standard deviation versus the two standard deviation. There can be three standard deviation. So let's take one another example on understanding the standard deviation. And so it's simple example. Calculate the standard deviation for this value 3, 12, 9, 4, 2. First, calculate the mean, which is nothing but 3 plus 12 plus 9 plus 4 and 2 by 5, which is 6. And then you calculate their standard deviation is like how far each of the observation is from the mean. For example, 3 minus 6 square, and we do it for other data, exactly the same previous example. So in this case, the standard deviation is 3.847. So this is how we calculate the standard deviation, which tells how far the observations are from the mean. So let's move to the next concept. which is the standard score. The standard score is very much related to standard deviation. It identifies the number of standard deviation away from the mean. So in simple terms, it computes how far an observation is from the mean in terms of standard deviation. Let's take an example. You are asked to calculate the standard score for this observation: 20, 25, 25, 34, 40, and 45. So the first thing to calculate the standard score is calculating the mean. The mean is 36. Then calculate the standard deviation. You know how to calculate the SD, standard deviation. The standard deviation is 8.6. The standard score is also referred to as a z-score. Z-score or z-score is computed as follows. As you can see in the table or data, 25, 34, 40, and 44. The way to calculate the z-score is simply 25 minus mean divided by 8 points. If you see 25 minus 36 divided by 8.6. So it is 1.28 times the standard deviation lower than the mean. If you see here, the mean is 36. So 25 is 1.28 times the standard deviation lower than the mean. That is how you have to read it, okay? Next data. Calculating of 34 minus mean divided by 8.6. So 34 is a point 23 times standard deviation lower than the mean. Similarly, 40 is above the mean. It is 0.47 times higher than the mean. So that is how you have to compute the z-score. Okay, so what is the importance of this? What are the standard for? 25 is 1.2 times the standard deviation below, and similarly, this is 0.23 times below the mean. It is negative because 34 is lower than the mean. Now let's understand the importance of a standard score. Now that we have computed a complex formula, what is the importance of standard score? The standard score is very important when you compare two things. As an example, Ali is a student who scored 30 on the first exam and 50 on the second test. Chan is one other person, a student, who scored 45 on the first test and 35 on the second test. So the first test mean of the class is 42. So the average mark in the first test is in English is 42 for the entire class. And the standard deviation is 7. These values are given to you, and in the second test the mean is 47 and the standard deviation is 8. The question you asked is who performs better, Ali or Chan? Ali scored 30 and 50. So the sum is actually scored 30 plus 50 and the total is 80. Chan scored 45 plus 34 and the total is same, it is 80. Both of them scored at the same rate in total, right? No, it depends on how Ali scored as compared to the mean in the first test and how Chan scored in the first test as compared to the overall class. Yes, compared to the overall class. So that will determine how each one of them performs. So as I said, both of them scored 80 in total. But the key thing is but the key thing is we are to see we are to see how good or bad they are performing with respect to the mean and the standard deviation. And summing up is not the right thing. So what you do here is calculate the z-score and to see how far Ellie is from the mean. You know the formula by it. Let's start with Ellie. So 30 minus 42 by 7 equals negative 1.71. We repeat this formula for test 2 and reach a 0.88. So here, if you add the score of these two, it's a negative uh, pointer, which implies that the standard deviation for the alias score is 0.84 times below the mean. We do exactly the same job, the same calculate for Chan, and finally we have 0.57. It means the Chan is only 0.57 times the standard deviation below from them. Both of them scored both of both of them scored below the mean, but Ali scored lesser compared to the mean, whereas Chan is just 0.57 times below, and it has a better number as Chan compares to Ali has a better score. So you need to create the standard score for both of them and then compare. So with this we have complete the dispersion measure also. Up to now we have discussed the measures. In the next video we will do it in Excel and how we get the mean, the median, the standard deviation, and the standard score. So yes, we will have a exercise in the next video.